non-inverting amplifier. So what's going on over here? This circuit over here that you see on the screen works as a non-inverting amplifier, or sometimes it's also referred to as a constant gain amplifier. Now, can anybody tell me what is the difference between this circuit and the one we did on Thursday, which was the inverting amplifier? Here, VP is connected to VS, okay? So basically you will have source input signal, okay? This is small input signal that you're trying to amplify, will be connected to the positive terminal. In the circuit that we did on Thursday, this input signal is connected to the negative terminal, okay? That's the major difference, major difference. Okay, now if you remember, if we, basically convert this circuit into kind of like a circuit model diagram, it gets a lot more easier just to apply voltage, nodal voltage analysis and KCL and KVL to get an equation for V naught and Vs. Basically what we are striving for here, again, we are trying to strive an equation to get for gain, which will be V naught over Vn, correct? Okay, so I'm gonna start off from, say, over here from the source, okay, from this point. Okay, so I have a source over here, okay. This source is connected to VP, okay, VP or V plus, both are same thing, okay. What happens over here, because I know there's a input resistance here and this input resistance is infinity, so how do I map this input resistor in a circuit model? That would just be an, is there any current flowing in here? No. So how do we model a circuit where no current is flowing? Just a open circuit, correct? So it will be just be an open circuit. This will be Vn, which will be the potential difference between the two. This node is basically what? This negative terminal, which is Vn or V negative. You can name it whatever. Okay, I'm trying to put both so you don't get confused, because if you're looking some other sources also, like some books, they use different. Some would use Vn, some would use V negative. Okay, now this node is connected to this resistor Rg, and then this is connected to the ground. This is Rg, and then this from here, this is connected to another resistor, which is Rf. Okay, and then you have this V out over here, VO. Okay, all right. Now, there's going to be a series of questions that I'm going to ask you, okay? And you can answer me in terms of variable or expressions. What is VP here? What is VP here?
It's equal to Vs.
Vs, okay, good, okay. Um, Vs, so if VP is equals to Vs, can I write down as Vn equals to VP equals to Vs? Is that okay to say that? Right, yeah. Because remember, Vn is, ideally you want it to be 0, and Vn equals to Vp minus Vn, correct? So if they are same, then only then you get 0, right? So if Vp is equals to Vs, then surely Vp should also equals to Vn also, correct? Okay, we need to find Vn here. I need to find Vn. Vn is the voltage which is at this terminal, correct? Okay, whatever the voltage is over here, same voltage will split over here and over here, correct? Over here, I have V out, VO. Can I apply voltage divider here and get the equation for Vn? Yes, folks. What would be that equation? Also remember, folks, you would think that this is the output voltage here. So the current may flow in this direction, and then you may have some kind of load connected to it, okay? Well, the current can also go into the op-amp, okay? So here you have V naught, you have V naught here. This goes over here. If I am able to find out the voltage across RG, then I can find out the voltage at this node. And because this makes a series circuit, so if I apply voltage divider such that V naught times RG divided by the total resistance, which is going to be the sum of these two, that would give me the value for Vn, correct? So let's do that. Vn equals to V out times you have RG divided by total resistance RG plus you get RF. Okay, all right. And because Vn here is equals to Vp Vs, so I can also write it down as Vs equals to V naught dot Rg over Rg plus Rf, correct? Okay, sweet. Now I need to rearrange this equation such that I get V naught over Vs equals to, okay, so which would mean I get Rg plus Rf over Rg, correct? Okay, and I can also maybe brush up this equation such that Rg equals to Rg plus Rf over Rg. This and this will cancel. So I get V naught over Vs equals to 1 plus Rf over Rg. Okay, can you guys listen to me? Can you hear me?
Yep.
Yeah. Okay. Yeah. Okay. Now, what is this V naught over Vs, folks? What is this V naught over Vs?
Gain.
Gain. Vs, it's your input signal. V out is your amplified version of the input signal. So this is actually the gain. This is the gain for you. And here is a very simple equation that if you choose the value for this RF and RG, you can say if you want to put a value of 1,000, it might be a little tough for 2,000 or any even number because you got this one right here. So approximately say gain of 1,000, say 1 plus. So if I choose RF 1K and then RG 1 ohm, so 1 plus 1K over 1 ohm will be 1K. So basically you'll get 1001, correct? Right? So that would be your gain here. Only so this is your non-inverting amplifier over here. The one we did on Tuesday was a inverting amplifier. Notice it has no negative sign over here in its expression over here, so you don't get a 180-degree phase shift. So both are widely used in AC circuits, but they just have two different equations in order to calculate the gain.